Right. Good evening. I'm Dr. Ho from Masa University. First of all, I would like to welcome you all to this audience webinar. Before this webinar begins, allow us to introduce the speaker's background. So this is Prof. Madya IR Dr. Ahmad Farid. So Prof have more than 20 years working experience in the area of power and energy. To date, he has involved as project leaders in various international research and grant. He also published a total of 87 scientific papers in his field of interest. He has actively organized and participated in seminar and short courses. Besides that, he was awarded Excellent Service Awards Anugerah Pendidik Harapan UiTM Anugerah Jaringan Alumni FKA. Without further ado, I would like to welcome the speakers to deliver the presentations. All right, Prof, the floor is yours.
Okay, thank you, Dr. Ho. Let me share my presentations. Okay, clear? Can you see my presentations?
Yes, I can see your presentations.
Okay. Good afternoons, and again, thank you for inviting me to share the topic of my research. And again, thank you to the Dr. Ho, who are going to moderate or chair the sessions. The title of presentations or the sharing sessions today is on the basis on power quality, where I a little bit change from the proposed title, the one that I have proposed to the masa previously on the monitoring. But when I come to the looking to the definitions or the works that I have done is more precisely to mention about the identification. So it's a little bit, but in terms of gist of presentation is still same, the flow is still same, and the content is still same. Okay, the intelligent system for disturbance identification in power quality. Okay, my name is Ahmad Farid Abidin. Currently, I have been with the College of Engineering, University of Technology Marash Alam. As mentioned by Dr. Ho, I have been involved in academic sector or academic world since 2000. That's almost or more than 20 years. Let me share to the overview of my presentation. I will start with the power quality. So it's better for us to have overview what is power quality all about. Some definition of power quality before we go to the framework of the intelligence system that we have developed or that we have played around since 2002 or 2001. And then when we talk about power quality, there will be something related to the not so quality. So we call it power disturbance. So we are going to discuss what is power disturbance all about. After that, I'm going to share what kind of the framework of the intelligence system that have been followed or that have been developed by the previous, the current, and perhaps the future researcher, because the framework is already there. It's just a matter of how we are going to deep down, how we are going to improve, or how we are going to innovate the framework that have been provided to us. And after that, I will discuss the work that we are focused on our research. Okay, I mentioned about us because I'm not doing this job or this research by myself. There are a few group that have been working that we have working together. Okay, we do have junior lecturer who are just joined my group, and we also have the technicians who are helping us on installing the power monitoring or the power logger, because when you deal with the high voltage or you deal with the power system, you need to have someone who are really have the certificate of competence to access the substation. Yeah. Because our works is deal with the real time or real data, so we need to have the data to capture the power the disturbance so that we can do the analysis we can pinpoint the problem, we can identify the power disturbance. And I will share a little bit why we are going, or we are really keen to identify disturbance. I will, after that, I will close up my sharing session with the summary. Okay, let's we go to the definition of power quality. Okay, this definition is taken from the power utility as well as the IEEE working power quality group. So, the power quality can be defined as the electrical system work properly, okay, without any interruption or less efficient within or with a specific characteristic voltage and or current. So looking to this information in these statements, the power quality is closely related to characteristic of voltage and current. So we cannot run away from the word of voltage or current. We cannot run away the parameter of voltage and current when we talk about the power, and it's really meant to the power quality as well. Okay, this is the equation of the power. As we know, when we talk about the engineering perspective, we talk about perspective, we talk about definitions, we also have to talk about the equation. So we cannot run away from the equation when we talk about the electrical engineering point of view. Okay, this is very basic or simple equation that I have. I think all of us are really familiar with the equation where instantaneous power equal to the instantaneous voltage multiply with the instantaneous current. So PT equal to the VT multiply with the IT. And if we look to the equation of VT or IT, our current or voltage is or should be in the sinusoidal behavior or the sinusoidal profile. So the equation can be Vm or magnitude of V sine omega t, or in some cases or in other cases, we also can write down the equation in terms of cos. So whether it's sine or cos is still similar in terms of profile or in terms of behavior of the signal. Just the matter of the phase angle is a differ. Okay, and come to the equation of it, which is equal to the Im sine omega t minus theta. Okay, why there is a minus theta? But okay, if we compare to the Vm sine omega t, there is no minus theta, but looking to the I, there is a minus theta. It's because of the nature. Okay, the nature of the electrical system is not really or 100% in terms of resistive value. Okay, when there is a resistive value, there is no theta. Okay, when there is a non or the system is not purely resistive, there will be existing the phase difference that we represent in term of minus or plus theta. Okay, basically the basic equation or the common equation taken by using the minus theta. Okay, it is because the assumption of the electrical power system is mostly in terms of inductive behavior. Okay, so when talk about inductive behavior, there is a lagging scenario that will be found in the current. Okay, that's the common sense in terms of electrical power system. Okay, when we combine the equation for P, V, and I in terms of sinusoidal functions, so we might get the equation of power for the instantaneous is Vm Im sin omega t multiply with sin omega t minus theta. It's very simple equation where we just multiply both sinusoidal functions into PT, okay, as a PT. So looking to the equation of instantaneous power. So power here is rarely or is highly dependable on the voltage and current, then we can say that the quality of power that come to us is okay highly dependent in terms of quality voltage and quality of current as well. So when we talk about the quality of power, it need to be reflected to the quality of voltage and quality of current. So we cannot run away. Again, I really need to stress that when we talk about the power, we cannot really run away. We cannot put aside the voltage and current. Okay, in order to obtain the good or highly quality of power, we need to have the voltage and current in or to be within a specific criteria we set by the power regulatory. Okay, we have to need some criteria because we want to say that the system have the quality. Okay, the voltage have kind of the kind of the quality. So what is definition? Okay, what is the criteria of the quality? So we need to really know what is the criteria, what is the characteristic that lead to the definition or that lead to the emerging of the criteria which help us to identify or to mention whether there is power quality or not. There is we need to have to some criteria, okay, so that we can identify, we can define this is the power is quality or this power is not in quality. Okay, before we go to the characteristic of the power quality, okay, now this is the criteria that commonly observed by the engineer or by the researcher who are working under power quality area. So we are talking about the magnitude of voltage or current. We are talking about the shape of the voltage or current. We also talking about the frequency of the voltage or current. So these are the criteria that have been used to set or to define whether the power is quality or not, whether we have the achieve or we have achieved the quality that we have set or the quality that we have won in terms of power quality perspective. Okay, so magnitude, shape, and frequency. This is three parameter that's being focused in power quality perspective uh, uh, for anyone who are involved in power quality area. Okay, uh, in term of combination of these three kind of the characteristic, so we need to have the magnitude. Okay, specific characteristic of magnitude. Okay, we need to have the shape of the voltage or current, whereby the ideal shape of current which is in a ideal quality of power which should be in a sinusoidal. And also we need to have consider the frequency, where the frequency is our system is 50 hertz and in some country is 60 hertz. So if you have the magnitude which is permissible, you have the shape which is perfect sinusoidal, and you have the frequency within 50 hertz, both combination or those three combination would produce the power quality. Okay, so this is the three item or the three combination of parameter which lead us to have a quality of the in term of power quality or in term of power. Okay, I mentioned before we need to have the very good shape of the sinusoidal, and in term of magnitude, if you have one per units, okay, we are talking about per unit. Why? Because the voltage in our system is varies depend on the area that we attach or that we install our equipment. For instance, if we are talking about the voltage at the transmission line, the voltage should be 132 or can be reached to the 500 kilowatt. It can also counted or to be 275. Okay, that's why we cannot put this very specific voltage here because different part will have a different kind of voltage. So in order to standardize the performance of voltage or current, especially voltage in terms of value, we need to have the per unit. Okay, where the best one is a 1 per unit. We are talking about 275 kV system. So the system or the voltage that being put or that being supplied to the system should be 275. Okay, if the voltage is, let's say, is voltage going down to 200 kilowatt, that's mean at 275 kilowatt. Okay, that's mean the in term of magnitude is quite low, so it reflect as well the quality of the power that being supplied to the consumer. Okay, now looking to the what we call it, the frequency. Okay, but in this case, in this waveform, I did not show the in term of time. But if we can have the some kind of measurement of the frequency from zero. Okay, and they go to the up and then going down backs, and then going to the zero crossing from 0 to 360. If we want to have the frequency of 50 hertz, the time should be 0.02 second. Okay, from zero, from this first point to the this kind of 360 zero crossing, the time should be 0.02 second. That reflect the frequency of 50 hertz. Okay. This is the ideal or the best case scenario that can be find or that can be found in the system. But bear in our mind, this kind of ideal scenario won't be happen in our system, because we won't get one per unit, we won't get the perfect 50 hertz, and we won't get the perfect sinusoidal of voltage as well as the current. Then we talk about the problem. Okay, we thought that something that deter the quality of the power. So any problem or any non-compliance to the quality of power known as power disturbance. Anything that deter the performance which related to power quality, we call it, or technically call it, as a power disturbance. In terms of definitions, what is power disturbance? Okay, any failure or misoperation of electrical equipment or system. When we talk about electrical equipment or system, it also reflect or it also counts the electronics. Okay, whether electrical or electronics is still considered as electrical equipment or system. Okay, which resulting or producing or originating from the voltage or current deviation from the given characteristic. Okay, any deviation from the characteristic of voltage and current which lead to the failure, which lead to the misoperation in electrical apparatus, is considered as power disturbance. Okay, however, the importance parameter is voltage. Why? Because the voltage is the one that can be controlled by the regulatory body. We cannot really control the consumer to use the system or to use the equipment which produce the sinusoidal current. We cannot ask the consumer. Okay, can we ask the consumer to stop using the personal computer? Because we know that personal computer is produce highly distorted waveform of current. We cannot ask, we cannot control, we cannot blame the consumer, or we cannot stop the consumer to use the what we call it, the non-sinusoidal, we call it non-sinusoidal load. When we talk about non-sinusoidal load, it will produce a non-sinusoidal current. What is non-sinusoidal current? Is a distorted, is non sinusoidal current that produced by the some load. So we cannot really pinpoint, or we cannot really talk about the current to control. We cannot specifically mention about the component of current, but in terms of voltage, there is some, or there is a much more what we call it, much more authority that can be used, or that can be what we call it, that can be reflected to the consumer application. Okay, so that's why if you look to the Tenaga Nasional Berhad or Suruhanjaya Tenaga, every characteristic or every electrical parameter that they mention in the books or in the regulatory books, they talk about the voltage. Okay, they are not talking about the current. Okay, this is the typical shape of disturbance that commonly appear in our electrical system. We have interruption, or sometimes they call it a voltage interruption, where there is almost zero. Okay, but though if we look here, it's a zero, but ideally there's a almost zero. Okay, there will be some voltage that appear in between the deep one or the almost zero one. There is almost some kind of the small magnitude of voltage. That's why we call it interaction. And we do have the voltage sag or also or voltage dip, where the voltage is slightly below from the nominal or from the normal value, and then it's up again to the normal situation after a few cycle. And we also have the voltage swell, where the voltage is slightly up or increase for a few cycle, compare or relative to the nominal value, and then going down again back to the nominal value after a few cycle. And harmonics is something that's created by most of our electrical load today, most of the electronics load today, where the pattern or the profile of the waveform is no longer sinusoidal. The shape is uniform. Okay, you can see that it's a repetitive, but it's no longer sinusoidal. And we have the notches. Okay, notches is the sharp hiking of the voltage for perhaps a microsecond, and it's happen in repetitive frequency changes. Okay, we can have a look that there is some frequencies going high in the middle of the shape or of the waveform because of certain problem. Basically, frequency changes is very rare happen in our system. Okay, it's quite a few that we have faced the frequency changes, because basically frequency changes is coming from the generator, okay, or generations. Since our generation is quite ample, our generation is quite sustainable, in terms of frequency changes is very rare to be happen to us. And we do have the spikes. Interference is known also a noise. And voltage fluctuation, where for the voltage fluctuation, the voltage is up and down. Okay, we can have a look over here, where at the first few cycle, the voltage is relatively high. After come to the second cycle, it's going down and it up again. So it's sort of the combination of voltage sag and voltage swell for the voltage fluctuation. Okay, basically, this event or this disturbance happened due to the starting off and starting on. Okay, where we off and we on the load, the big load. Okay, this create the voltage fluctuation. But normally, in our electrical system, especially in Malaysia, 80% of the power quality is due to the water sag. Okay, this is the one that is a predominant disturbance that commonly appear in our system. Okay, looking to this illustration, I try to put it in a simple way, where voltage duration or current duration plus failure or misoperation is known as a power disturbance. Okay, so if there is no failure, though we have the voltage duration, we cannot say this power disturbance happens. If failure or misoperation happen, but there is no water duration and current duration, we cannot say the power disturbance happen again. So there is a two combination, voltage or current duration plus the failure or misoperation. When these two scenario happen, when these two scenario that we have facing, then we can say that power disturbance happen in our system. Okay, this is the example of the power disturbance which create the misoperation or maloperation of our devices, which lead to the burn of the socket or this kind of what we call it the protection device. Okay, we have the water situation where the voltage is happen to be dropped, we known as water sag, which lead to the burn of the protection device. Okay, because of the water sag. So this is some one of example that I want to illustrate to the participant. This is the way that we define the power quality or the power disturbance. Okay, looking to the framework of intelligent system, we talk about intelligent system in power disturbance identification. We want to identify the power disturbance. We need to have case. We need to have an issue. If there is no case, then we cannot have the power disturbance identification. Okay, so we are really need to assemble or need to accumulate the data which have the power disturbance in which appear or which experience by electrical system. Then once we have the power disturbance, we need to conduct feature extraction process, and the final part of the framework is the decision making, which we use to give the uh, output, such as what kind of disturbance, what type of disturbance, okay, where is disturbance happen. So it called is decision making that help the sorry, that help the engineer or that help the troubleshooter to identify what is the problem that happened in our system. Okay, this is where we can if for those who are really want to uh, try or to propose or to write the proposal on the FRGS, we can focus on this kind of the framework. Perhaps you can have a look at the case, how we are going to analyze the case. Okay, this is also one study or one research area that you can, one proposal that you can write down for the FRGS. You also can have a look to focus on feature extraction. Okay, focus on the feature extraction only, and write the proposal on the basis of feature extraction. And also you also can have a look, you also can have a propose on the decision making, focus on decision making. Okay? This is the way where we can try or to develop the fundamental knowledge which really align with the fundamental research grant and the Ministry of Education or Ministry of Higher Education. Okay, in our case or in from my experience, I have tried on the basis of feature extractions. The first one is only for the speech recognition. The second one is for the power quality. So for feature extractions only, we managed to secure two FRGS grant. So this is where we can pinpoint the focal of the fundamental research area, which really follow the requirement of the FRGS. Okay, what is the case of our disturbance? This is the problem or the electrical disturbance which occur in the system. We need to have the expert view because some of us are not really go in depth what is power quality all about. So we need to have the collaborative work with the power quality expert. Okay, like me myself, I need to work with my co-supervisor at early stage of my studies, where he is the one who are really expert, or he is the one who are have experience working on the power quality, and he is the one who mentioned to me this kind of power quality, this type of power quality happen in the power system. Okay, where should we install the power quality monitoring system to gather the data? Okay, where is the what kind of the equipment that we need to use to gather the data related to power disturbance. Okay, we really need to work with the experts in terms of power quality so that our monitoring, our data accumulation is really relevant to the one that we want to observe or to conduct the research. And uh, what is the purpose of the we conduct the case because we want to classify the different type of disturbance, or perhaps we want to identify the source of disturbance, and perhaps we also want to predict the condition of the power system related to power quality. This is the three main, or perhaps more. Okay, but in our focus, or in my focus, we are focusing in this three kind of the research area, or research work, where we want to classify the different type of disturbance. We also want to identify the source of the disturbance, and the third one is we need to predict the condition or the situation of power related to the power quality situation, where for the number three we need to develop the indicator so that it can give us uh, the ideal, or what we call it, the situation, how good the power, or how good the quality of power in the system. Okay. uh, for the case, okay, that's why the one that I mentioned to you related to the case, for the FRGS, for those who are really want to shoot or to focus or to try the FRGS, you can, or the participant can have some sort of the modeling based studies. We have the situation, we have the case, and in order to construct, in order to what we call it, to create or to redesign, redevelop the case, we have to create or simulate the case on the basis of the simulation software. So this is very important actually, because if we are really depend on the measurement or on the power quality measurement, some of cases we cannot, or the number of cases is sometimes is not really big in terms of number. So we need to create, or we need to simulate the disturbance by ourselves. Okay, this is the very simple circuit that we develop to simulate the harmonics in our system. Okay, this is a different kind of source that create the different, based on the frequency, different frequency, and it will create the harmonic disturbance in our system. Okay, the next stage is the feature extraction. Okay, feature extraction is to make the features more visible before we fed to the decision making. Basically, the feature extraction using the signal processing technique, statistical technique, and definitely we also can use the mathematical tools, solely mathematical tools. Okay, if else tools also we can be used for these feature extraction techniques. Okay, kalau if we look here, there is some symbol which related to the signal processing technique. This is a wavelet transform, the blue one, and the brown one is a S transform, and there is also the Fourier transform, which being used in the power quality area since 1980s. Okay, the old one is a Fourier transform, then it evolved to the wavelet transform. Now we have S transform. Okay, again there is a different type of transformation that being valuable in the system to extract the different kind of power quality scenarios nowadays. We also need to have the statistical tool. We can use the means. We also can use the standard deviation. Okay, some of study also use the ANOVA technique. So there is a different statistical technique that can be used to be deployed in our studies on the basis of power extraction or feature extractions module or feature extraction process. This is how the features being extracted. Okay, this is our raw signal. okay, when we conduct the signal processing technique for the extracting the features, okay, the first or the earlier or the bottom one is the original signal. Okay, the second one is the original signal which have been removed or have removed the spike one. Then the D4 until D1 is the high frequency portion that have been extracted from the original signal. So if we want to identify or we want to fit the input for decision making operations, this is the data. Actually, D4, D3, D2, and D1, the one that we can use to be fed to the decision making. Okay, so that is much more visible. Kalau kita lihat, if we can look here, this is straight line, and then there is a ripple or a sharp up and down, and then again straight line. So this is very clear features for the kind of disturbance that we call as a transient over there. Okay. Okay, this is also the example of the wavelet transform that have been used to extract the features. The first one is the normal one. Sometimes we have to conduct the base studies. Okay, we need to compare the problematic one and the ideal one. So the first waveform is consists of the ideal situation or ideal waveform, and the second waveform is the waveform that consists of disturbance or problematic waveform. So from this comparative, we can develop some criteria to differentiate the ideal situation and the problematic situation pertaining the power quality issue. Okay, this is another feature extraction technique with on the basis of S transform spectrogram. Okay, we can have a clear waveform over here. Okay, for from 6.8 second, the waveform are in a nominal or in a normal condition. Then come to the vortex from 6.8 to 7.6, and then gaining back to the nominal voltage from 7.6 to the 8. So if we transform or if we look to the features for S transform spectrogram in terms of color, okay, uh, clearly we can have observed here the waveform or the spectrogram with the red one, which consists of a nominal voltage, and the nominal of the yellow one is consists of the what we call it voltage sec, and back to the nominal one which consists of the red one. But this spectrogram is yet to be fed, or is not able to be fed to the decision making yet, because we need to do further process the features so that the features is more visible, the features is more what we call it, more in term of differentiated the nominal and and the problematic one. Okay, and then back in our mind, when we talk the features that we want to fed to the decision making or to the next process, it should be in term of a number. Okay, it should be in term of possible 0 and 1. It can be it should be in term of numerical values, because our system or our engineering system are working in term of number. Okay, so from this kind of the illustration or the spectrogram, we need to translate in term of number or in term of numerical before we fed to the decision making to give us what kind of disturbance appear or experienced by us. Okay, the last stage of the intelligence identification is decision making. Basically, we are working with the artificial intelligence. Okay, it gives decision based on the human needs, and we know that AI actually they imitating the function of human brain to the computer application. Actually, it's coming from the human brain function and being translated in terms of mathematical formula and embed in terms of computer to be used as a intelligent decision making. We call it artificial intelligence. So we have different kind of the artificial intelligence nowadays. We have the different kind of the neural network. We do have the fuzzy logics, and also we have the machine learning. So machine learning also can be some consider is different kind of artificial intelligence. Some people say that artificial intelligence is different in machine learning, but again, the process is still same. It's coming from the imitating of the human brain to the computer applications. Okay, now I would like to share some of the works that have been conducted by my students. Okay, this is collection of data. Okay, the cases we coming from the are coming from the raw data collections, which using on the PQ analyzer, and also sharing from other works. And we also use, as I mentioned previously, we also use the simulation data to get enough number of the case of power disturbance for the further analysis. And looking to the next process, which is feature extraction, we have the signal processing by improved ST. Okay, there is some modification that have been conducted by my student to improve the performance of ST. Okay, and with the combination of the ANOVA for the statistical operations, and finally we are working with the support vector machine to make a decision the location of the PQ, that the PQ disturbance that appear in our system. This is another works that have been conducted by another students. Okay, but the students only the case only coming from the simulation works for the case, and he is working on the continuous S transform. So features extraction based on the standard deviation, mean and variance, and also deploy the ANOVA, okay, to detect the fitting line, and come to decision making where the probabilistic neural network and support vector machine have been used, okay, to classify the power quality disturbance in our system. Okay, we also conduct the study on the high neutral to earth voltage. Okay, this high neutral to earth voltage very something that unique happen in Malaysia. It's also happen in other countries, but not as much as Malaysia. So we as a power quality research group at UITM, we conduct the study on the location or the localization of the high neutral to earth which happen in our system. Okay, when we identify there is a appearance of the high neutral to ground or high neutral to earth voltage, from that kind of the we call it anomalies or disturbance, we are going to segregate or divide the disturbance in terms of three different causes, where there is a non-linear loads, loose connection, and lightning. So if there is a high neutral to ground issues appear in our system, we can suspect it's coming from from the non-linear load. It can be coming from the loose connection. It's coming from the lightning, which is lightning is external factor, where non-linear load and loose connection is internal factor. So it's much more easy for us to pinpoint the problem that have been faced in the system, which related to the high neutral to ground voltage or high neutral to earth voltage. Okay, this is how the simple neural network works to identify the disturbance which is related to the high neutral to ground voltage or high neutral to earth voltage. Okay, we put into two output, which is neutral to ground voltage due to the harmonics and neutral to ground voltage due to transient. Okay, if due to transient, we can go in detail where transient can be classified or can be related to two issue, which is loose connection as well as due to the lightning. Okay, so this is a sample of the data that we take. This one is a real data. Okay, real data. We conduct the wave transform, and there is also some statistical analysis or statistical tool that have been used, and we use the Marquardt neural network to classify the disturbance which focus on the high neutral to earth voltage. Okay, this is the same case. We have feature extraction and decision making based on AI. Okay, this is the same thing, but just the method of we use the different type of the neural network, where we use the coherent neural network in this case. Okay, now how important is intelligent disturbance? Okay, so why we are really keen to identify or to focus on the intelligent disturbance? Okay. First, by identifying the disturbance that appear in our system, this is a way that we minimize the financial losses by pinpointing the root of cause. Uh, I have experience where there is cases that the owner of the ship facing the problem with the electrical issue. The battery at somewhere in the system are not also always having the problem to supply the what we call it to the system, and then the battery also, the lifespan battery also very short. Okay, somehow when they call the consultant, the consultant just replace the battery, but behind the probability issues, there is a power quality issues that have been experienced or appear or have been in the ship. Okay, so if we are wrongly diagnosed the problem related to electrical situations, we might face a highly or massive financial loss. So, by pinpointing the root of cause on the basis of power quality studies, we can minimize the time, minimize the losses due to the financial, because we are really in the know what is really happen, what is the real problem happen in our system. It also can play a role as a preventive maintenance, where the power disturbance could deteriorate the performance of equipment. Okay, if we capture the power disturbance in the power system, uh, we can mitigate that kind of disturbance. And when we manage to mitigate that disturbance, it can sustain the lifespan of the equipment. Okay, in some cases the power disturbance did not give some sort of the burn or misoperation. Okay, uh, but in a long run it can affect the performance in terms of lifespan. So by identify the power qualities disturbance that appear in our system, we mitigate it, and in term of lifespan of the performance, or in term of lifespan of equipment, we can sustain or we can secure. And the last one is safety precaution, where the power disturbance could lead to electrical hazard, such as the high neutral to ground voltage. Okay, high neutral to ground voltage, that means there is a voltage that appear between the metal, what we call it, the metal enclosure, to the ground. So when you touch that metal enclosure, it can trigger the current, and the current could flow to your body because there is voltage over there. The voltage coming from the high neutral to ground voltage. It could come from the high neutral to ground voltage. So the safety precaution also can be related to the power quality issues. Okay, when we know this power disturbance, especially related to high neutral to ground voltage, we minimize, mitigate, then the safety precaution is there. So, in terms of intelligence system, currently we need to produce fast identification system to solve the PQ issue via the power disturbance identifications. And also nowadays, the power system, electrical system is become more complex, and it's hard to expert personnel to identify the root of cause. So we need to develop the intelligence system to assist the experts, or the electrical experts, pinpointing or mitigating the issue related to the power quality. Okay, moving forward, this is the area of power quality that we can explore with the virtual instruments, wireless system, mobile phone application, the smart meter. We can integrate the power quality in the identification with the smart meter, and the imaging of the electric vehicle, as well as the renewable energy, will produce the new dynamics or the new kind of power quality issue in our system. Okay, there is some different scenario if we compare the non-RE system with the RE system. Okay, there is a different kind of the power quality issue that we are experience under RE and non-RE system. And the use of IoT and cloud-based analytics also can be further exploited to be integrated with the devices for measuring, monitoring, and identifying the power qualities. And overall system, which whether it's virtual instrument, wireless, mobile phone, smart meter, IoT, and emerging, we can integrate all together into smart grid. Okay, the smart grid is a very massive topic, and power quality is one of the topic that can be being exploited or closely related to smart grid. Okay, uh, the importance of development of real-time online system is very crucial, because we need to do, or we need to really produce the fast decision action. Nowadays, the time is a very precious. Okay, if we manage to develop the fast real-time online system for power disturbance identification, is very highly demand in our industry. With the advancement of the interfacing switch system in data acquisition, it will help us to accelerate the performance, accelerate the real-time online system, and plus with the wireless device also could bring the disturbance identification more interesting. So this is the three important scenario, or three important component uh, that is can be exploited, or can be further observed, or can be further developed for those who are really interested to follow or to be in power quality disturbance identification area. Okay, in the era 4.0, this process become more interesting due to the availability of advanced computing tools and techniques. Again, what I've mentioned before, the emerging of smart grid, distributed generation, and new type of electrical load uh, will produce, or already produce, the different type of PQ scenario, and which lead to the more flexible, more advanced PQ identifications or power disturbance identifications. And as I mentioned, if you go to the journal, or you go to the what we call it, anything related to the energy area, it's really difficult to find the word power disturbance. But power disturbance is the one who support, the one who are really aligned or really engaged with the area of the RE, for instance. is the one who can be exploited, the one who which can be used with the user, for instance. So power quality is not the one who are really so-called the niche area or the bombastic area nowadays, but it's remain relevant because anything related to the electrical use, anything related to electric application, there will be a power quality, there will be power disturbance. So as far as PQ is concerned, uh, anything related to electrical situation, anything related to electrical system, there will be power quality issue, there will be power disturbance identifications that to meet need to be resolved or need to be observed. Okay, with that, thank you. Over to you, Dr. Ho.
Okay, so thank you, Prof, for the informative and interesting talk. So, Prof clearly explained regarding on the power quality and power disturbance. So, even though I'm not from electrical field, but I understand well about the powers and are interested to learn more on this. So, I hope that these presentations will be beneficial for everyone. Thank you for your attention. We will end the webinars and good
Okay.
evening.
Okay, thank you.
Thank you, Prof.
Okay.